We're moving along in Chapter 13. We're at Cramer's rule for a system of two equations in two variables, and I have a theorem for you. We have 5 previous videos that are linked in the description for your quick access. So determinants have many uses, and one is to solve a system of linear equations that contain the same amount of variables as there are equations. So there's 2 variables, there's 2 equations. And remember that a system of 2 linear equations in 2 unknowns, 2 variables, it'll correspond to a pair of lines. And if the lines are parallel and distinct, there's no solution to the system, and it's inconsistent. And if the lines are identical, well, there's many solutions, and the system is dependent. And if the 2 lines meet, they cross at a single point, then there's a single solution to the system, and the system is consistent and independent. So the determinant of coefficients is non-zero if and only if the system is consistent and independent. Now, if you're confused about determinants, see the previous video, 13.3a. There's a link in this description to get to it quickly. All right? So what it's saying is, if the lines meet at a single point and there's a single solution, then the determinant is a non-zero. Okay? The coefficients. The determinant of the coefficients is a non-zero. All right? So we have a system of 2 equations, each in this linear equation standard form, ax plus by equals c. And you can see our little subscripts that this is the first equation and this is the second equation. And by eliminating the variables, we get our solution. So for x, this is what we're going to do. We're going to take the first c and multiply it to the second b. Then we're going to do the second c and multiply it to the first b. So we're kind of crisscrossing here. And we subtract those values. Then for the denominator, we take the first a and the second b and get a product. And then we multiply the second a with the first b and we get a product. And then we subtract those. And now we have our value for x. And then for y, we do way over here to this C2, and then way over here to this A2. We subtract them, and the denominator is the same as the x. It's this one, and we get a product. This one, we get a product, and we subtract it. Okay? And the numerators and denominators of the expressions for x and y are determinants. These are determinants. We're cross-multiplying, aren't we? So here's our theorem for Cramer's rule in 2 equations. The system of 2 equations in 2 variables, we have our first equation, our second equation, has a solution given by this diagram. Okay, so let me back up a little bit. So you can see we've got the C1, C sub 1, and the B sub 1. And we're going to cross, aren't we? We saw that in the last video. You're going to cross-multiply, and then you're going to subtract the products from each other. And then for the denominator, we're going to do the same thing and subtract the products. For the y, we're going to come way over here and cross and multiply, and way over here to the A2, cross and multiply, and then subtract the products from each other and get an amount for the numerator. And then the denominator is the same as this one. See that? It's as long as these aren't a 0, okay? So notice that they share the same denominator. And the denominator is the same for both variables, and it has the coefficients for x and y in the same positions as the original equation. The first a, the second b, the second a, the second b, see? And we refer to this determinant as d. So this one is d, okay? And it's easy because it's like denominator, okay? So, for x, we get the numerator by replacing the x coefficients, those a's, the a sub 1 and a sub 2, in d by the constants, the c's. So here's our denominator that they shared, okay? That was this a sub 1 times the b sub 2, and the a sub 2 times the b sub 1, and then we subtracted. And we got that d for both of them. But now for the numerator, we're going to cross-multiply this way, see? And for y, we get the numerator by replacing the coefficients, the b's, in D by constants, the C's. All right? And I'll go into a little more detail. I'll show you with real numbers in a second. Now, if D is a 0, then one of these situations is going to occur. One of these things will happen. If D is a 0 and the determinants of the numerators are also a 0, then the system of equations is dependent. That means the lines are identical and there's many solutions. If D is a 0 and at least one of the other determinants is non-zero, then the system is inconsistent. That means the lines are parallel and there's no solution. All right? So stick with me. So here's some real numbers. We can solve using Cramer's rule. So remember, these are the A values, the B values, the C values. All right? And we have our first and second equation in our system. So for D, we're going to do the 2 here times this -2. We're going to cross this way. See? And then we're going to do the 4 times 5. Then we're going to get our denominator. Our denominator is going to be a -24. All right? We had a -4 minus 20, so we got a -24 for our denominator. Now for the x and the y's, we're going to cross multiply here, and we're going to get a 7 times -2. We're going to cross multiply here, get a -3 times a 5. We're going to subtract those. We're going to have a -14 minus a -15, and we're going to end up with a 1, because we add the opposite here, don't we? We're going to get a 1 over a -24. Now for the y, we're going to do the 2 times the -3 crossing this way. Then we're going to do the 4 times the 7 crossing this way. We're going to subtract those values and get a -6 minus 28. And that's going to be over that -24, that D. And we're going to have a -34 over a -24. Well, these cancel out as a positive, don't they? And we can divide both of these by 2 to get a 17 over 12. So that's our solution. We have, for x, we have a -1/24, and for y, we have 17/12. So what we did was, for this system of 2 equations and 2 variables for Cramer's rule, we had the c and the b from the first equation and the c and b from the second equation, and they were over the a and b from the first and second equation. And then for y, we did the a and the c from the first and second equation. See that? This was the c and b, this was the a and c, and they share the same denominator, all right? So this is what it looks like graphically to the equations. What we're doing for the denominator is we're multiplying these, and then we're subtracting, all right? So these, like right up in the front of the equation, the a's and the b's, see that? For the numerator, we're cross-multiplying in the back, see? With the answers in the b's, and then subtracting. For the numerator for the y, we're crossing from the front to the back, from the front to the back, getting a product, and then subtracting, see? So that's Cramer's rule, and you can use this to solve a system of equations. In a couple more videos, we're going to talk about what happens when you have a system of 3 equations, all right? So our next video is 13.3c. And we're going to talk about the determinants of 3 by 3 matrices. There's going to be a link to those 5 previous videos for Chapter 13, and I'll put this in the Algebra 2 playlist. And now you know Cramer's rule, and you can use it to solve a system of 2 equations and 2 variables. And now you know a new theorem, all right? Keep trying, and I'll see you next video. Bye.